Close your eyes for a second and imagine this. You're strapped into a seat on top of the most powerful rocket ever built. The engines ignite beneath you. 200,000 pounds of thrust punch you into the sky, and as the clouds disappear below, you realize you're heading somewhere no human has gone in over 50 years. That was Artemis 2, April 2025. 4 astronauts, 1 loop around the moon, and then straight back home. It worked perfectly. But here's the thing, that was just the warm-up act, because what comes next is something so ambitious, so complicated, and so historically significant that it makes Artemis 2 look like a test drive around the block. Today, we're breaking down everything. The rockets, the landers, the companies competing for a NASA contract worth billions, the technology that's never been attempted before, and why the entire future of human space exploration depends on what happens next. This is Artemis 3, and it's going to change everything. The moment Artemis 2 splashed down safely in the Pacific Ocean, NASA didn't pop champagne and take a vacation. They got straight to work. First order of business, assess the mobile launcher tower. After Artemis 1, that tower took a brutal beating. Fire, shockwaves, and vibration tore through the structure. Engineers spent months reinforcing and rebuilding it specifically to handle faster turnaround times between SLS launches, because time right now is NASA's most valuable resource. Here's the good news. Every major component for Artemis 3 is already built. The solid rocket boosters, done. The core stage, done. The Orion spacecraft, done. It's all sitting there, waiting to be stacked and rolled out to the pad. So what's the problem? The problem is that NASA can't land people on the moon with just a rocket and a capsule. They need something else. Something that can descend from lunar orbit, touch down gently on the surface, keep astronauts alive for days, and then blast back off and rendezvous with Orion waiting above. They need a lunar lander. And this is where the story gets genuinely fascinating, because the competition to build that lander has turned into the most consequential corporate rivalry in the history of spaceflight. Back in 2021, NASA made a decision that surprised a lot of people. They awarded SpaceX a contract to convert Starship, their enormous upper stage vehicle, into a human lunar landing system. At the time, Starship looked like a stainless steel grain silo with legs. It would hop a few kilometers into the air, fall back down, and roughly half the time, explode on landing. It was exciting in the way that watching a bonfire is exciting. Impressive, a little dangerous, and not exactly something you'd want to stake human lives on. But SpaceX kept pushing. Over the next 3 years, Starship evolved into Starship Super Heavy, a 2-stage rocket system standing nearly 400 feet tall. The most powerful launch vehicle ever constructed, more thrust than the Saturn V that carried humans to the moon in 1969, more thrust than the Soviet N-1 that kept exploding trying to match it. Test flights got progressively better. The ship began making it to suborbital trajectories, then splashing down in the Indian Ocean. Then, in a moment that genuinely looked like science fiction, returning to the launch tower and being caught mid-air by giant mechanical arms. The progress has been staggering. But, and this is important, it has been slower than Elon Musk originally promised, which, if you followed SpaceX for any length of time, is essentially the company's defining characteristic. The timelines slip, the ambition stays enormous, and somehow, eventually, they deliver. In May 2026, SpaceX is scheduled to launch Starship version 3 for the very first time. This is not a prototype. This is what the company considers the finished product, the vehicle they genuinely believe can carry humans to the lunar surface. And when you look at what the lunar Starship offers astronauts, it's almost absurd. 9 meters wide, a cavernous flight deck, a docking port at the very top of the nose. When crew transfers from Orion into Starship, they'll enter the most spacious vehicle ever designed for lunar operations. The entire Apollo lunar module would fit comfortably in just the airlock. In May 2023, just days after Starship's first orbital attempt ended in a spectacular explosion over the Gulf of Mexico, NASA did something unexpected. They handed out a second lunar lander contract, this time to Blue Origin. The reaction was skeptical. Blue Origin had spent years launching wealthy tourists to the edge of space on their New Shepard rocket. A few minutes of weightlessness, a nice view, back home for dinner. Critics called it a space theme park. The serious heavy lift work? That was SpaceX's territory. But Blue Origin had been building something bigger. Their heavy lift rocket, New Glenn, finally launched in January 2025. First flight. The upper stage reached orbit successfully. The booster came back down and exploded on landing. Rough, but for a first attempt on a vehicle this size, actually impressive. Then November 2025 changed everything. New Glenn's second flight went perfectly. The upper stage deployed 2 satellites on a trajectory toward Mars. The booster executed a flawless soft landing on an ocean platform. With a single launch, Blue Origin transformed from a punchline into a legitimate competitor. Their lunar lander, Blue Moon, is a different design philosophy from Starship, more compact, more architecturally refined. The crew cabin sits at the bottom, with fuel tanks stacked above. The docking port connects from the side at the base of the habitation module. It's more modest than Starship's cavernous interior, but compared to the Apollo lunar module, it's a palace. And in May 2026, Blue Origin is attempting something historic, launching Blue Moon Mark 1, a smaller cargo version of the lander, all the way to the lunar surface. Uncrewed, just payload. But if it touches down successfully, it proves their technology works end-to-end, and it transforms Blue Origin from a late arrival into a genuine threat. Here is the technical challenge that doesn't get nearly enough attention, and it might be the hardest thing about this entire mission. Both Starship and Blue Moon are massive vehicles, enormously massive, and mass requires fuel, a lot of fuel. The problem is that by the time either lander travels from Earth orbit to the lunar surface and keeps enough fuel to launch back off the moon, there simply isn't enough propellant capacity on board to do all of that in one shot. The solution is orbital refueling. Top up the lander's tanks while still in Earth orbit before making the long trip to the moon. Simple in concept, extraordinarily difficult in practice. Because here's the thing, nobody has ever transferred propellant between 2 spacecraft in orbit before, ever. In the entire history of human spaceflight, spanning over 60 years, this has never been done. For SpaceX, the plan involves launching a second Starship dedicated entirely to carrying propellant. It meets the lunar Starship in low Earth orbit, docks, and transfers liquid oxygen and liquid methane through a connection in space. Blue Origin will deploy a separate propellant transport vehicle that performs the same function for Blue Moon. This means that before NASA's SLS rocket even leaves the ground, 4 additional launches need to happen successfully. 2 landers reaching orbit, 2 tankers docking and completing propellant transfers that have never been attempted before. We're not talking about one historic milestone here. We're talking about 4 happening in rapid succession, all of which need to work before the main mission even begins. Both landers are fueled. Both are waiting in low Earth orbit. The countdown clocks are running. The SLS ignites. 4 astronauts, a new crew, not the Artemis 2 team, thunder into orbit aboard Orion. And then, instead of burning toward the moon, they set a rendezvous course for the landers waiting nearby. The pilot manually guides Orion toward the first lander. This isn't theoretical. On Artemis 2, pilot Victor Glover practiced exactly this maneuver, steering the capsule toward Orion's own spent upper stage to simulate a real docking approach. Now it's real. Scenario 1, Blue Moon. Orion approaches from the side. Docking port connection at the base of the habitation module. Hatches open. The crew floats through into a compact but carefully designed living space. Practical, efficient, every centimeter purposefully used. Scenario 2, Starship. Orion approaches the nose. Crew transfers up through a tunnel into the flight deck. 9 meters wide, multiple levels, the kind of space that makes you forget, just for a moment, that you're floating in vacuum 200 miles above Earth. Now the work begins, and it's relentless. First, systems shakedown. Life support, power generation, propulsion, communications, thermal management. Every system exercised, monitored, stressed, any anomaly documented and analyzed. The whole point is to find problems here, in Earth orbit, where rescue is theoretically possible, rather than discovering them while descending toward a crater on the Moon. Second, manual flight practice. The crew undocks from Orion, maneuvers the lander independently through space, then redocks. This sounds straightforward. It isn't. Landing on the Moon requires precise, confident vehicle handling. This is where you build that confidence, without the Moon's gravity trying to pull you into the ground. Third, and perhaps most fascinating, the spacesuits. Axiom Space has designed entirely new lunar suits for the Artemis program. Different from the suits used on the ISS, different from the bulky, barely mobile suits worn by Apollo astronauts. These are engineered for agility, designed to allow a human being to crouch, reach, and work on the lunar surface without fighting their own equipment. They've been tested underwater, which simulates some aspects of weightlessness. But the genuine test, exposure to actual hard vacuum, actual temperature extremes, actual space, happens for the first time right here in the airlock of the lunar lander. Astronauts will seal their helmets, cycle the airlock, and open the outer hatch to space. If anything is going to fail, better to find out now. NASA estimates the full test program will take approximately 3 weeks. 3 weeks of near-continuous operations, data collection, and problem-solving. Then the crew returns to Orion, undocks from the landers, and heads home. The Earth orbit test is complete. One lander has proven itself more capable, or both have. Now comes the final exam before humans are cleared to ride one of these vehicles all the way to the surface. An autonomous, uncrewed moon landing. The winning lander, or both if both performed well, flies to the Moon without a crew. It executes the full landing sequence independently. Engine burn to leave Earth orbit, transit to the Moon, lunar orbit insertion, powered descent, and touchdown on the surface. If it works, the company that built it is officially certified to carry humans to the Moon. This step cannot be skipped. The original Artemis 3 plan, which involved astronauts entering a lander for the first time while already in lunar orbit, then attempting a landing with essentially no prior testing on the actual vehicle, was, to put it charitably, an aggressive risk profile. The revised plan is simply smarter. Verified everything, then land people. NASA's is linked per visit and anything in the Moon. NASA's given me 2 Verifas fly Artemis 4 within 1 year of Artemis 3. 1 year. That timeline creates a pressure that goes beyond engineering. It's a manufacturing challenge, a logistics challenge, a supply chain challenge. Whoever wins the lander competition doesn't just need to build one vehicle. They need to build them continuously, reliably, and fast enough to support an ongoing lunar program. This is where the competition between SpaceX and Blue Origin gets genuinely interesting from a business perspective. SpaceX has the advantage of experience. They've been building and flying rockets at a cadence no other company has matched. Blue Origin has the advantage of a billionaire backer with effectively unlimited patience for investment and a more methodical engineering culture. One prioritizes speed, one prioritizes precision. Both are necessary for what comes next. Here's the question worth asking. Why does any of this matter? Why is NASA moving this fast? Why is the US government spending tens of billions of dollars on moon missions when there are problems right here on Earth? Because the Moon is no longer just a scientific destination. It is a strategic asset. The lunar South Pole contains water ice in permanently shadowed craters. Water that can be split into hydrogen and oxygen, rocket propellant. Whoever establishes a permanent, functioning presence at the lunar South Pole will have a refueling station at the gateway to the entire solar system. Mars, the asteroid belt, the outer planets, all of it becomes dramatically more accessible from the Moon than from Earth. China understands this. Their space program has been advancing at a pace that Western analysts consistently underestimate. They've landed rovers on the Moon. They've built their own space station. They have stated plans for a crewed lunar landing before 2030 and a permanent lunar base by 2035. This is not a scenario where America can afford to arrive second, plant a flag, and call it a victory. The nation and the company that builds permanent infrastructure on the Moon first will have an outsized influence on how humanity expands beyond Earth. The rules, the norms, the economics of space, all of it gets shaped by whoever is there first, with the most capability. That is the actual stakes of Artemis 3, not a flag, Not a photo opportunity, not nostalgia for the Apollo era, the beginning of a permanent human presence beyond Earth. So let's bring it all together. Artemis 3 isn't one mission, it's a cascade of firsts. The first orbital propellant transfer in history, done twice, simultaneously. The first real-world test of two competing lunar landers in space. The first time new generation lunar spacesuits meet actual vacuum. The first uncrewed autonomous moon landing in the modern era. And then, Artemis 4, humans, on the surface, SpaceX or Blue Origin. Starship or Blue Moon? Honestly, we don't know yet. And that uncertainty is exactly what makes the next 2 years so compelling to watch. What we do know is this: humanity is going back to the moon. Not for a visit, not for a photo, for the long game. And the clock is already running. If you want to follow every step of this story as it unfolds, subscribe, hit the bell, and drop a comment below. I want to know, which lander do you think makes it first? See you in the next one.